Hello, a warm welcome from HGT University. I am Dr. Ashok Yadav, Faculty of Agriculture Sciences. Today we are learning about the breeding of grapes.
Breeding of grapes, center of diversity. European grapes Vitis vinifera belong to the family Vitaceae having a chromosome number is 2x38 is considered to have originated primarily between the Caspian and Black Sea region. American grapes belong to a large number Ubitis and Muscadania species have originated in the North America referred to as a vineland by Zelensky. Germplasm resources field gene bank of grape are maintained at Division of Fruits and Horticulture Technology, IARI New Delhi, Indian Institute of Horticulture Research, Bangalore, Ganesh Khand Botanical Garden, Pune. Further, 616 genotypes of grapes are maintained at IIHR, Bangalore. The objective of breeding of grapes are to develop early maturity, seedless and sweet cultivars of the table purposes, to induce resistance to the anthracnose, phylloxera and chafer beetle, to develop variety with the medium vigor and productive basal buds, which can be trained on head and pendle system of training for the tropics. The objective of breeding should be to develop high yielding and high quality variety with increased fruitfulness of the basal bud, less degree of apical dominance, suitable of the different purposes such as table resin, wine and juice, and resistant to the disease. Introduction. Grapes are reported to have been introduced to the tropical India about 2600 years ago in 620 BC. Commercial cultivation did not start until the beginning of 20th century. During the 1930s, Sri R.S. Pillai identified Anabaceae from the collection of Nawab Akbar Ali Khan, and subsequently its commercial cultivation picked up in the South India. Bhokri and Chima Sahibi is Maharashtra, Bhokri and Muscat Hamburg in Tamil Nadu, and Bangalore Blue in Karnataka are to the introduced. The commercial variety of grapes were introduced into the India mostly by the invaders of Iran and Afghanistan. Muhammad bin Tughlaq introduced Bhokri, Fakhri and Sahibi cultivars in Aurangabad and Daulatabad in 1338. Breeding through selection, open pollinated seedlings segregate from the large number of characteristics and hence the population of seedlings from the open pollinated seeds is an potential source from the selection of the desirable types. For example, Chima Sahibi, selection 7, selection 49, some promising seedlings from open pollinated population of the Pandhara Sahibi, Kabul Monoka were also selected. Clonal selection is also one of the methods of fruit improvement due to the natural mutation in exciting cultivars. Considerable variation occurs between individuals that help in the varietal improvement through the clonal selection. The promising clonal selection of the grapes are as follows: Tas A. Ganesh, Thompson seedless of colonial parents, developed by Mr. Aru of Bargaon in Sangli district of Maharashtra. Its berries are quite elongated and respond to a GA3 treatment. Rao Sahibi, that is called the Chima Sahibi or selection 7, having a colonial parents, isolated by Rao Sahib Kadlag of the Sangamanar in Nasik district of Maharashtra. Hybridization in grapes are highly heterozygous and are proposed asexually at the commercial scale. Inbreeding result in the rapid loss of vigor and fertility of the vine. Even in the first generation, the crosses of the unrelated parents with good combining ability, followed by the rising a large number of hybrids seedlings in the each combination and rigorous selection, may result in good ideotype of the commercial use. In India, hybridization work was started in 1958 at IARI New Delhi. The purposes of hybridization at IARI New Delhi was to develop early maturing, high yielding, better quality seedless variety with resistant to the biotic stress. However, IIHR Bangalore started breeding program in 1968 with objective to the develop superior variety for table resin, wine and juice purposes on the basis of types of the parent used. It can be grouped into the two interspecific, intergeneric hybridization and interspecific and intervarietal hybridization.
Flower of grape is actinomorphic hermaphrodite pentamerous, male and female found on the same inflorescence, ovary superior, bicarpellary, borne in the leaf axil of the raceme inflorescence. They having a nectiferous flower to attract the insect for the pollination.
Intergeneric hybridization in Muscadania is a rich sources of resistance to the disease and pest and also possesses a unique and delightful flavor and aroma. The crosses between British and Muscadania, which differ in the chromosome number, are made with the difficulty, but most of the resulting hybrids remain sterile. The pollen of the rotundifolia will fertilize the egg cell of the British benifera, but reciprocal crosses is less successful. Partly fertile F1 hybrids 2x/39 can crosses reciprocally between themselves of or with British benifera into British rotundifolia, which have been further improved by the backcross with British benifera, resulting in some fertile vines that produce acceptable quality of the table grapes. Olmo 1971, that is giving the report. Crossing within the Muscadania has given outstanding self-fertile cultivar like Thurhill, Muscadania rotundifolia, into the Muscadania monsoniana, Southland, Morgan, Wrigley, Cold Hardy, Sterling, Cold Hardy, and Trumpf bronze-colored berry weighing 7.9 gram. Intervarietal hybridization. In grapes, a few promising hybrids identified through the intervarietal hybridization at IARI were hybrid 6237, the cross of her into Pusa seedless, H62-65, that is the cross of her into Pusa seedless, H62-22, that is the cross of her into Black Hamburg, H62-67, that is the cross of her into Bharat Early, H63-10, that is the cross of Bhokri into Pearl of the Cassava, H63-32 is the cross of Bhokri into Pearl of Cassava. In 1996, cultivars Pusa Navrang, that is Madeline Angevine, cross Ruby Red, and in 1997, Pusa Urvashi, that is the her into Beauty seedless, were released from the IARI New Delhi. The promising hybrids developed at IIHR Bangalore were Arkavati, that is Black Champa into Thompson seedless, Arka Kanchan, that is Anabe Sai into Queen of Vineyards, Arka Syam, that is Bangalore Bilu into Black Champa, Arka Hans, that is the Bangalore Bilu into Anabe Sai, Arka Chitra, that is the cross of Angur Kalan into Anabe Sai, Arka Krishna, that is the cross of Black Champa into Thompson seedless, Arka Majestic, that is the cross of Angur Kalan into Black Champa, Arka Nilmani, that is the cross of Black Champa into Thompson seedless, Arka Soma, that is the cross of Anabe Sahi into Queen of Vineyard, and Arka Trishna, that is the cross of Bangalore Bilu into Convert Large Black, Arka Sweta, that is the cross of Sweta seedless, yani Anabe Sai into the Thompson seedless. Hybridization technique in grapes, it is including the choice of parents, emasculation, pollination, shortening of the breeding cycle for the early assessment, growing of the hybrid seeds, and planting in the field of assessment of the selection. Number 1 is the choice of parent in order to incorporate the desirable characters of the one cultivar into the other hybridization. The knowledge of inheritance pattern and general and specific combination ability of the varieties is very essential for making choice of the parent is restricting the cross combination and more seedless population for the better selection. The viability and germination ability of the hybrid seeds are also important factor in deciding the parent to be used in hybridization. It has been found that in some cultivars, when used as a female parent or the shaft, the seed germination is poor and sometimes do not germinate. For example, the cardinal, even if in such cultivars are required in hybridization, they should be used as a male parent in order to induce seedlessness in the progeny. It would be better to select a variety having high seed index as a female parents. Cultivar Angur Kalan can also be used as a female parent for the earliness, seedlessness and good quality, but for the same purposes, cultivar Beauty Seedless, Perlate and Pusa Seedless should be used as a male parent. Emasculation and pollination. Emasculation of small flowers of the grape is a tedious job. Since the grape is self-fertile, emasculation is most essential for the making desired cross. Use of reflex stamens and functionally female cultivars like her Angur Kalan, that is Bunquebite, Katta, Kurgan as female parents can help in the eliminating the tedious task of the emasculation. Iyer and Randhawa reported that aqueous solution of malic hydrazide MH at 400 to 750 ppm 2,3,4 triiodobenzoic acid TIVA at the concentration of 400 to 500 ppm and 1,2-dichloroisobutyrate FW450 at 0.30% applied twice to 13 to 15 days old inflorescence induced pollen sterility. When emasculation is completed, the emasculated bunches are baked and pollinated with the desired male parent very next day. Mutation breeding in grapes may be attempted as a complementary tool in the grape breeding for one or more important characters. Without altering the whole genetic setup, the important mutagens used in grape breeding are physically mutagens X-rays and Y-rays, chemically mutagens ethyl methane sulfonate EMS and nitroso and methyl urethane NMUT and N-nitrose and methyl urea NMU. Further induced mutation have resulted in a few improved varieties. New perlate, that is the loose perlate with comparatively loose bunch, has been evolved with the X-rays, that is the dose of 2.5 kr treatment on the perlate. Self-thinning property of the new perlate is the result of meiotic irregularities caused by the chromosomal translocation. Red Niagara, having a red fruit from the Niagara, and Rovin Cardinal, an early maturing variety from the Cardinal, are other important induced mutation in grapes. Polyploidy breeding in grapes has immense importance in the improvement of table grapes. The chief benefit from the polyploidy is the increase in the berry size. However, autotetraploids are found to be the considerably sterile and are less productive than the parents. The crossing of diploid with the induced tetraploids may help in the evolving new triploids seedless grape. The triploids are highly sterile. All tetraploids, even between infertile species, have been more desirable as a commercial varieties. Colchicine is generally used as an aqueous solution of 0.25 to 5% with 5 to 10% glycerin to induce polyploidy. Marble seedless from the Delight early Nevele, that is the cross of Campbell into Niagara, Loneto early gain from the Campbell, Muscat Common Hall from the Muscat Alexandria, Black King from the Campbell, Bellis gained from the Concord, Case from the Sultana are important example of polyploidy. Biotechnology in grapes. Embryo rescue techniques Seedlessness is a desirable character for the table and raisin grapes. Inheritance of seedlessness is postulated to depend on two complementary recessive genes and only about 7.5% of the total progeny from the crosses between seeded and to the seedless grapes produced fruit without noticeable seed traces. The embryo rescue theoretically increase the proportion of the seedless progeny as it makes possible to the cross two seedless varieties. Ovules are excised before abortion and are cultured on the either filter paper in liquid medium or solid medium. Genetic engineering in grapes or plant transformation. Some encouraging preliminary results have been obtained on agrobacterium mediated transformation of the grapevines, but the production of genetically transformed grapes wine which express a marker gene is yet to be reported. Protoplast culture in grapes. Protoplasts are of the great importance as tool for the genetic amelioration and somatic hybridization, but regeneration of the grapevine from the protoplast has not yet been successful. Anther culture in grapes can result into the haploid grape vines which can be developed into the homozygous diploids by doubling chromosomes. The homozygous diploids will be very useful for the producing F1 hybrids and for making genetic studies, but there is a low success rate of the generation of the grapevine from the anther and only one cases of haploid has been reported in grapes.
So today we covered the breeding of grapes. Next time we meet you, we will be exploring about the breeding of papaya. Keep learning, keep growing. See you next time.